Might seem like this is bad, but if you spin it though. Okay, the field service manual makes this a little bit confusing because the procedures are a little different depending on the type of repair you're doing and how far apart you're going to have the motor. So I'm going to try to simplify this to make it less confusing. So I've watched videos where people don't actually do this procedure and they just remove the cams as they are at the top dead center positions where all the marks are aligned, and you could probably get away with that, but you are running a risk of actually damaging the cradles because while the left-hand side will have relieved spring pressure on the valve train, the right-hand side will not unless you do this procedure that's described in the field service manual. So if you don't do it, you're potentially going to have the spring pressure from the bucket pushing on the cam and actually potentially stressing the cradle and damaging the cradle, which is where the bearing surface of the head is. The left-hand side is pretty simple. Basically, anytime the cam is put in or removed, it's going to have the lobes of the cam in basically this triangle section. You're going to have one cylinder vertical, one cylinder to this side, one cylinder to the other side. This is looking at the motor from the front, and these are represented, these are the outer cylinders or the frontmost cylinders that you can see. So the left-hand side is pretty simple. These cams are actually taken out and put in with these alignment pins in the 90-degree position. This is where the timing marks on the gears are actually going to align with the cam caps. So these are already at a relieved state. The right-hand side is not. So basically the procedure to remove would be you would turn to the top dead center compression of the front cylinder here, and then once you are at this position, so this side is going to be intake side down to the left, exhaust up, and then these two are going to be kind of pointed toward each other. Neither valve is depressed because you're in the compression stroke. This is where you can remove the main timing chain. All right, so once the main timing chain is off and all four cams are at the timed position, all the pins are 90 degrees to the valve cover surface. You're going to want to take the crank and rotate it back about 40 degrees counterclockwise. This is basically going to lower this front piston that was at top dead center, and it will ensure that none of the pistons are in the way of the valves, so nothing can impact and get damaged. Once this is cranked, then you will be able to rotate these cams back about 70 degrees or so. So you want this exhaust lobe to be vertical and then this intake lobe to be down this way. It's basically the same position as this other side. So, but the pins you can see won't be aligned. They won't be at 90 degrees anymore. That's just because these aren't depressing the valves at the same time on both banks. So this is the trickier side. You want to rotate before you remove them. This is where the lobes should be. And this is the same for install. When you install them in the same position. Both pins are about somewhere around 20 or 30 degrees off of the gasket surface there. Once they're torqued in position, then you can use the hex portion of the cam and rotate them up to where the pins are at 90, as it is here. Once those are there, now you're in the time position, and these lobes will be pointing to each other again. This is where you want to add, it specifically says put the big sprocket on, and then put the secondary tensioner, and then you can add the chain and your small sprocket. So, and if this doesn't pop onto the boss and the pin smoothly, then you can just gently wiggle this cam and it should pop on. So don't try to force it on, you can damage it. It's probably just very slightly misaligned. Give it a wiggle, it should pop on. Then you can torque both of those sprockets on, and now you are again at the time position. So once you are at, all these timing marks are aligned and they're linked with the secondary chains, you can remove the pins from the tensioners, the two small tensioners. Now you're linked and you're ready to put the crank back to the top dead center position. Once this cylinder is again up to top dead center, then you can put your main chain back on and you're going to align the paint marks. You've got corresponding paint marks of one color for both sprockets here, both sprockets here, and then you've got the other color, I think it's yellow, that will go on the crankshaft gear, and it's going to be at the 9 o'clock position. There's a little dot on the sprocket. I'll probably throw a picture in there, but that is how you will want to do it. So really quick again, to remove, you go to top dead center compression, you remove the main timing chain, you crank back about 40 degrees, then you can freely move these to these two positions and unbolt them in the proper sequence. And then again, when you put them back in, you're going to put them in these two positions. Once they're torqued in place, then you rotate them so the pins are at 90. Then you can put the sprocket and all that on. Once everything is at the time position, you can put the crank back to top dead center, put the main chain back on. Once you're here and the gear is off of this little keyway and not connected, you can rotate this back and you'll feel spring pressure actually want to push the wrench to where these lobes are vertical to take it out. So if I rotate back, it's like very easy, and it wants to stay in that position with these lobes vertical, because the other lobes are, this one's that way, this one's this way. They're both kind of equaling each other out, and then this has got nothing on it. Once you've got this cam out, you can remove the tensioner bolt and kind of weasel out the tensioner. I had to kind of pick up the gear to get it out of the chain. Once that's out, you can pull the front sprocket, or not the front, but this little sprocket out, and then get this whole chain off. This guy you don't really need to take off unless you're replacing something, because once it's disconnected, it doesn't really matter. And the same thing with this cam, you want to rotate counterclockwise again, and these front lobes will actually be pointing down almost to where they're going to start depressing the bucket, but they won't be, and the back lobes will be close to vertical. So it's again just equalizing that spring pressure, so there's nothing fighting you and potentially damaging the caps when you try to unbolt it. And the sequence is going to be 1, 2, 3, 4, and then you skip this guy and go 5, 6, and then 7, 8. And then just carefully lift this guy to not damage any of these surfaces. Make sure you keep all the buckets in the positions where they're at, because they're all individual to the valve length, and that's how all of your valve clearances are set. So do not mix those up. But at least the caps are labeled, but I think they're only labeled for the side. You can actually mix them up to the other side, so don't do that either. Keep them all individually with where they are. All right, I got this in time, so this makes a little bit more sense. So you can see my marks. So when these are clocked and you align them, there's going to be the little notch for the pin on this sprocket. There's also like a slight green paint on the sprockets. I don't know if you'll be able to see it. Mine have a little bit of green paint on the tips of the sprockets. That will align with your timing mark. You have a single line on this side, which will align with this second mark off to the side, and then the back sprocket will align with the first mark. You can barely kind of tell. There's a little bit of paint on that to the left of my finger. So those are slightly off. That's fine. This one has a double line, so the timing mark is kind of at the tooth of the sprocket in between these two lines. Same with the rear one. You've got like a slight amount of paint. That line's there. Obviously, they're one unit. And then the dot that's on the front will align with this timing mark. So at that position, you have both of these timed. That's when you can safely put the crank back to top dead center, which is basically, I might get a diagram here because I covered it up. There's going to be a timing mark, and there is a dot on the, I think it's the position sensor sprocket thingy, the wagon wheel looking thing. There's a dot that lines up with this seam in the cover, and then there's another dot that will point, it'll basically be at the horizontal plane pointing to the left, and that's the dot where the yellow link on your main chain will go. So you will need to have the two, I think it's an orange link that goes on your timing mark here on your main sprocket, timing mark here. It'll be on those two lines, like matched up with that. And then the yellow will go down at the bottom and it will match to that dot. Once that's all there, you can put your idler sprocket or your tensioners back in, or whichever way you did it. The manual says to use the idler sprocket. I never took that off. I just did it with the tensioners out of the way. Once that's all in place, all your tensioners are in place, you can remove the pin from your main tensioner and get chain tension, and then you can rotate. 2 times will be a full cycle of your cylinder, and you can verify that everything will be in time again. Okay, I was going to go over just a bench valve check, since I didn't actually check the valve clearances before I took the head off, just because I knew that some of these valves may be changing after anyway. And the motor sounded really good when it was running, so definitely make sure all these caps are going back to the exact spots where they were before, or your adjustment's going to be all screwed up. This is actually my setup for what I did to hold all of the buckets. So those are in order, and I have arrows pointing to the front. I have left bank and right bank. So that'd be, or passenger, driver, whatever you want to do. The heads also do say left hand, and I'm assuming right hand on the other side. So the tightening sequence on this is the reverse of removal. So I'm actually going to start here. So it'll be 1, 2, and then go to this big main cap. It'll be 3, 4, then 5, 6, 7, 8. And just snug it up a little bit at a time. And these I'm not torquing, I'm just getting them snugged somewhat tight, just so the cam won't move and I can get an accurate reading. And then I'm going to take this back off anyway when I go to put this back in. So, and the other reason here to do it on the bench is that I can just freely spin this and not worry about the valves hitting pistons or anything. And then if I need to change it, it's just easier on the bench. I can pull everything, change a bucket here rather than bending over the truck. And the other thing I'm doing is I have it on 2x4s just so when any of those valves come out, they're not going to impact anything underneath. So yeah, I'm just going to start checking here, and I'll start with this guy since they're vertical and I can get my feeler gauges in there, and then I'll just spin it as I need so I can check clearances on the other ones. Should be pretty easy this way. And the shop recommended doing it one at a time. And now I see what he's saying. He just said it should be way easier to get a feeler gauge in from this side. Okay, I just want to go over this mess that ended up happening on my table. So I usually do a little bit more neatly than this, but I happen to be working on a table with cardboard on it, and since this is drawn the same orientation as the heads, it just kind of made sense for me to start doodling my numbers on this. So this dark line is just the middle between the two banks, and then these two in the center are the intake, and then the two outsides are the exhaust. And I just took a note of, as I put the buckets in, I was cleaning them and re-lubing them, so I was just taking a note of the numbers here that are underneath the buckets, because the buckets are the shims. So each of these numbers corresponds to a certain thickness, and they offer, I think, 35 different sizes. Apparently now only even numbers, like 36 and 40. I happen to have like 33s and 41, stuff like that. I don't know if they don't make those or what, but the chart I found doesn't show those. So I think they just stopped doing it, but I'll probably put that chart right here. Basically, between each size, so between like a 34 and a 36, it's 8/10 difference in thickness, so not quite a thou per shim size. So you can either use the chart, you can probably find that online, or I find those kind of annoying usually, so I like to do it just with math based off of my my shim thickness and my clearance, and figuring out what shim will give me the right clearance after that. So basically I went through, I wrote all these numbers to record all the shim buckets that I have at each cylinder. And then I went through and I noted my clearances on each cylinder, on each shim. And the reason to record them is because afterward I could basically look through, and if you have any that are out of spec, you might be able to fudge a few buckets and swap them to actually get your clearances better without actually having to go buy any. So these exhausts, I have like 4 up here that are a thou out, and then 1 here that's a thou out. I'm not going to worry about it. I mean, usually valves will get tighter over time, especially exhausts, so I'm really not stressing a thou. But I was a little more concerned on this intake side. This cylinder had 10 as the top, and this was an 11 and a 12. So the 12 was a little like, it's a little bit on the loose side for me. And then I called 2 different dealerships, and one didn't have any shims on hand, and then the other one couldn't find any sort of part number to reference because they were the repair stock, I think. So he wasn't even sure if he could sell them, and the parts manager was not there to make a special deal for me or anything, and he couldn't really help either. So I was like, well, I'm just going to look and see what I can do with what I have. Basically, so if I have a loose one and I want to make it tighter, I've got to look for, I'm kind of transferring clearance if I want to swap shims. What I had to do is find one that's on the tighter end that could allow for a thinner shim to get more clearance. So kind of the options that I had were these 3 here. I had 8 thou, 8 thou, 8 thou, and I had a 34, which is too close to the original sizes. These are both 33, so it's almost the same. But then both of these I happen to have 36s, so like a thou and a half ish thicker. So, and these are both at 8. So I was essentially I swapped both of these. You can kind of see my arrows. I just popped this one over here, flip those, flip these 2. So this went from 8, theoretically it was going to go up to around 9. Same with this, about 8 to 9. And then these should both drop roughly about a thou. So I swapped them, and these both went back down a thou. So this one's now in spec. This one's only a thou out instead of 2. And then both of these, instead of 9, they both went up to 10, which is still fine. That's the top of the intake tolerance. So that worked out pretty well, actually. So yeah, if you record everything in some coherent way, potentially even better than this masterpiece, you can kind of play musical shims and just move stuff around whatever way works. And then you don't technically have to go recheck, but I just wanted to recheck so I knew that things happened as I thought, and that I didn't make a mistake, and that the math is mathing and whatever. So I did put the cams back in, double check, and they were, I mean, these were within a thou. These were dead on. So all right, some more knowledge gleaned from the shop and the manual. So I've seen videos of people doing the head gaskets and just soaking the entire bolt in oil. Like one video actually had all of these just in a bag of oil, and they were pulling them out, and just basically oil was flinging out of the bag as they were dropping them in the cylinder. And you really don't want to do that for 2 different reasons. So the manual specifically says put a light amount of, or a light coating of oil on the threads. It doesn't say soak the bolt. And the shop specifically told me only oil the top of the washer. Don't soak the washer in oil either. So you want oil just on the threads, and then the underside of the bolt head or on the top of the washers. I laid them out and just did one side. And the reason for that is, number one, if you oil both sides, it'll reduce the friction significantly. And apparently ARP did some testing where they did it both ways. And I guess if you coated the whole thing with oil and had oil on both sides, they were torquing something like 40 or 50 foot-pounds more. So extremely, extremely over-torqued versus what it was supposed to be. It just makes a massive difference. So this way, basically, the washer will not likely spin on the head, and you're just going to have reduce the friction between the washer and the bolt head. And it should be the right amount that way. Because if you do over torque these, you're actually overstressing the bolt, and you're reducing the strength of the holding power, basically, and you're increasing the chances of a head gasket failure or bolt and then head gasket failure. And then the other reason for not soaking the bolt is basically when you put it in the hole, you don't want oil to be seeping into the head gasket surface. So you don't want to, like, as you put it in, if it's not tight, you can potentially have like drops of oil basically going in between the two mating surfaces where the head gasket is, and then you might tighten it down, have oil trapped in there, and eventually that causes a failure too. So the shop said that can cause a failure, and I'm inclined to believe him because he seemed to know what he was talking about. He also said if you want to do it, you can potentially put two bolts and just kind of snug it down in place so the head gasket is kind of sandwiched tight, and then you can start putting your oiled up bolts in, and then take out those two dry bolts and then put the two new oil bolts in and then snug them together. And that's another way to prevent oil from potentially dripping in between where you don't want it, because you do want it all dry, the gasket surfaces and the gasket all dry. With the engine in the time position, I used a protractor here along the gasket surface to find the exact angle of the flat on the crank sprocket, and that way I was able to transfer the angle perfectly to the oil pump in the timing cover. Just make sure that you flip it around 180 degrees because your view is actually changing from toward the back of the truck to toward the front of the truck. I initially did this by eye and I found it to be quite off, so I'm glad I did this, because the last thing I wanted to do is be fighting with oil pump alignment when the form in place gasket is drying extremely quickly. You only have a few minutes to actually install this, so I do really recommend that. Another thing I wanted to mention, this is another O-ring that for some reason the valve grind kit that Toyota calls it, they don't include these. I don't know why. These are I think they're the VVT solenoids, little valves. Mine are pretty squared out and flattened, as you can see. So I got some just from a kit that I have. It's an 18 millimeter OD by 2.4 thickness. That fits pretty well. I think once it smashes in there, it'll fit pretty well. And what I did is these slots make it annoying to, I didn't want to, they're kind of sharp edges, so I didn't want to roll a new one in there. So I just put a layer of packing tape, and that blocked all those. The new one slides right on past all that stuff, no problem. You don't have to worry about damaging it. And now I'm going to figure out which size that guy is and also clean it because it looks gross. So this other O-ring is slightly bigger. It's about 1 millimeter bigger. So I found a 19 millimeter OD by 2.5 thickness. I also had a 2.4 thickness. That would probably also work, but then I found this in my other kit. I had a 2.5 thickness. So it fit a little tighter. The other one was like barely kind of loose on the smaller section there, even though it kind of gets squished into it. But this is basically snug on the groove and will fit in your valve cover. One more thing to check and clean out before you get too far while you're at it is these little filters right there. It's just ahead of your exhaust manifold area. There's one on each head. Pull that guy out and there's a screen. It comes out like this, and there's a little crush washer on it to seal it, and this just pops apart, and mine is full of crud, so I'm just going to blast all this and probably just use this mass airflow stuff because it's plastic safe, and clean all that trash out of there and then put it back in with the Loctite 242, which is the blue. Yet another tip, if you happen to be replacing your tensioner, I took this opportunity since I'm doing the head gasket. I don't know when these have been changed, so I'm doing all the idlers and the belt together. You should replace them together because they wear together. I did have one idler that was really bad, so all those are getting changed. If you are changing the bracket, chances are that this part where your alternator sits is not going to be exactly the same as the old one. So this guy here is what I can best call a draw nut. So essentially it's pressed in there, but it has a piece preventing it from turning, but it's able to start out and then get drawn in to sandwich the bracket. So I was about to torque the new one in, and I thought, maybe I should check this really quick. And sure enough, this was probably about 10 or 20 thou too tight, and I would have been fighting that in the vehicle So instead, I set this end on a wood block, and I took a piece of material, anything flat, aluminum's always good. I set it over the top, stuck a punch in there, and just gave it a few whacks to open it back up until this would fit in there nice. So now it does, and then when I retighten it, it's going to re-sandwich on this new size, and you won't be cursing inside bent over the bumper. Something else to note, this has a weird torque sequence, which I'm assuming puts extra stress on this top bolt, because Toyota says to replace this top bolt anytime you take this off. I've heard of people replacing these and doing this 150 times with different trucks, not the same bolt obviously, but 150 jobs doing this and never replaced a bolt, never had a problem. I don't know, it's for some reason it's a fatigue thing. I think it might have to do with the length. As you can see, the top bolt goes through a lot more, so it's probably got potentially more stress and tweak on it, plus it's closer to the pulley. I don't know. They say to replace this one. And the other weird thing is the other 4 bolts are the same, but you're supposed to tighten those 2, put these in all the way, and then torque these, and then torque the other 3. And they're all the same torque, 27 foot-pounds, so that makes it even more confusing. But yeah, for whatever reason, replace that. It's like $2, $3, something like that at the dealership. So I figured, well, why not? Might as well. No idea. If anyone knows, that would be interesting to hear. The last tip I will leave you with is my experience with my truck. I'm assuming it's going to be similar to yours. I was concerned about oil pressure on first startup, so I did use engine assembly lube. I used the Permatex Ultra Slick on all of the valve components, all that stuff when I put it together, so I wasn't going to have a dry start as much as possible. I don't know how long that stuff lasts, so I really wanted to wait till I got actual oil pressure to actually start the motor, just because cranking RPM versus even idle RPM is, 1500 RPM idle. I don't even know what cranking RPM, it's nowhere near that. So I would rather turn it slower and wait for oil pressure to rise rather than waiting for the engine to do it. If you want to crank without it, I'm pretty sure you pull, it's like, I think it's C/open or C/op, this guy. And then I pulled my EFI fuse, which is this 20 amp yellow, and that will allow you to crank the engine without having it fire on you. So I was actually getting nervous because I cranked it probably 5 or 6 times for about 7 or 8 seconds each, and I still had the oil light on the dash. And I was like, uh-oh, like I would have thought it would have gotten oil sooner. I actually did. I poured some oil down the oil tube here until it was actually full. To help, I poured some oil in here, but obviously you can't pour much in here just because you have to flip it over. And even then, it probably took, I would say, close to a minute 20, minute 30 seconds of just cranking before the oil pressure light started going out. And I double checked it, like it finally went out. I let it sit, so it came back on. I cranked it again, it went out. I'm like, okay, I'm confident. The sensor is right here, and I was like, I'm plugged this in. I know I plugged it in. So yeah, I would definitely do the cranking to get oil pressure back and just get oil through the whole system, to do as much little damage as possible to anything that's kind of been dry from sitting. Once that's there, you can put your fuses back and pray that everything goes well and you start it and it sounds great. I give you the blessing. Yes, sir. Anyways, I think that's it. I hope this helped you out a bit and you can get your truck fixed for less than $3 or $4 grand or whatever and do actually a better job.